Okay, so in this class, see, till now what we have studied. So till now we have studied what do you mean by a multi-threaded application? What do you mean by main thread? So how does the main thread works? So what is the use of main thread and how you can create a thread? So there are two ways of creating a thread. One is by implementing the runnable interface, and the second method is by using the class called thread class, where you are extending that thread class. And after that, we have also seen some of the methods like sleep method, get name method, set name method. And apart from that, the states of the thread, how and or the life cycle of the thread. So we have seen some states like a thread can be in running state, a thread can be in a ready to run state, a thread a suspended state. So all those things, and also priority with respect to the priority of the thread. A low priority thread can be removed from the CPU, and a high priority thread can be given the CPU. So when we have multiple threads, the priority will be given to the thread which is of higher priority, or a thread can also voluntarily give the control CPU also. So that is like till now we have studied this thing. So in this class, we will talk about how we can create multi-threads, how we can create more than one thread. So far we have created, a main thread and a child thread for that. So in this class, I will write a program. I will write a program to create multiple threads, meaning it can consist of three or more threads. So that is also possible. So we can create multiple threads, and we can see how it will run. So that is also we can do. So when I create three threads, all the three threads will share the CPU. So when I create five threads, all the CPU, like all the five threads will share the CPU. So we'll just start with the first program, which is creating a multiple threads, which is creating the multiple threads. Once I've created the multiple threads, then um, we can start with um, the other concepts. So first I will just write a program where you can create multiple threads in Java. So I'll just write a program now. So, why I'm showing this example is, so you just need to know. So you need to know that it is possible to create 5 threads, 10 threads based on the requirement. So most of the time will be so in your lab exams, in your lab um, class also, you would have created a multi-threaded application where you would have created 3 threads. So we'll just look into that. So after that we will proceed with what is this alive method and join method. So since so there is one program, no, so I'll just extend this program, that's all. So we have one program where I'm implementing the runnable interface, where I'm implementing uh, the runnable interface, and it is uh, what it is overriding it is implementing the run method, where it is just typing a message called uh, thread is running. So the same way I will create multiple threads. Now I will create multiple threads. So what I will do means first I'll just make some changes to this program. um, So I'll create a class. So I'll just delete all these things. I'll, I'll create a class. So see, we are following, what we are following is here, we are following a method where we are creating the thread using runnable interface. So that every whatever program I write, so I'll be creating the threads by implementing the runnable interface. So I'll give some name. I'll just give some name called, I'll just give it as multi-thread. I'll just give it as multi-thread. It will implement the runnable interface. It will implement the runnable interface. Um, After this, so I've written a class. I've declared a class thread. It will implement the runnable interface. So inside this runnable interface, what I will do means I will declare a string to take the name of the thread. So this will contain the name of the thread and a thread reference variable. We need a reference variable when we are implementing the runnable interface. So I've done created a program by the name multi-thread. It is implementing the runnable interface. So for this, I'm declaring two variables. One is the t, which is the which is a reference for the thread, and the second one is the name, which will contain the name of the thread. So after that, I'll just create a constructor. I'll create a constructor which is given by the name multi-thread, the name of the class. So it will take what this constructor will take means it will take the thread name. It will take the thread name as the parameter. So it will take the name of the thread as the parameter. Um, after this, uh, the name I will assign to the name I will assign. This is the statement to assign the thread name. Statement to assign the thread name. Then I will create a new thread. Then I will create a new thread by calling the object and the name of the thread. So after this I'll just print the thread name. I'll just print the thread name. So it is taking some time. System.out.println. So what is the name of the thread? It will be my new thread. I'll give it as a new thread. Then what else? It is the new thread is stored in the reference variable t. So I'm printing the name of the thread. So after this, so the see what this constructor is doing means, so whenever I'm calling this constructor, for example, I'll give the name of the thread as my thread. So the my thread, if I give the name of the thread as my thread, so the my thread will be assigned to name, and this will be my new thread. So the my new thread name will be the my thread. So that is what this line is doing. After that, I will start the thread. How to start the thread means we have to call the start method. We have to call the start method, which will start the thread. So this is one part. This is one part. So after that, we have run method. So uh, name for containing the name of the thread. The t is a reference variable for the thread class. So after this, whatever name I'm passing, I'm reassigning it to the name. What constructor is doing means it is getting the name of the thread from the main class and like from the main function, and it will store it in a variable called name. So after that, I'm just calling the start method. So now the logic, I will write it inside the run method. So the logic, I'll write it inside the run method. So public void run. What logic I just want to means I just want to print the numbers. So for printing the numbers, I can write it like for int I equal to, I'll print from 1, I equal to 1, um, I less than or equal to 5. I'll print it till 5, I plus plus. So what I will do means I'll just print the numbers. I'll just print the numbers. Um, so system, I'll just copy this. One second, it is taking time. Okay, I'll just print the numbers. Okay, so it is not. It is taking some time. I will type it. System.out.println. System.out.println. So what I want to print is I just want to print the numbers. I just want to print the numbers, but I will be calling this run function. I'll be calling this run function from three different threads. I'll create three different threads with three different names. So the name of the thread, the thread. If I call the first thread as T1, so T1 will print 1, 2, 3, 4, 5. So if I give as T2, T2 will print 1, 2, 3, 4, 4. So the which thread is printing. So this name will give me which thread is printing. Um, which thread is printing the numbers followed by what I want to print, followed by and this is just a thread one is printing and the value which I want to print, it is stored in I. So what this line will give me means if I give the name of the thread as my thread 1, my thread 2, my thread 3, my thread 4, my thread 5, like this it will give. So this will contain the name of the thread which I've given as the parameter. Um, whenever I'm creating the thread. So we know that after printing that, I want my thread to pause for some milliseconds. So for pausing the thread for some milliseconds, I'll use the sleep function. I'll use the sleep function. So I want my thread to pass for 1000 milliseconds. So like that, I'll write the statement. So whenever I'm using this sleep statement, I have to write it, some interrupted exception might occur. So I have to write this code within the try block. So I have to write this code within the try block, and in the catch block, and in the catch block, I have to use the interrupted exception. I have to use the interrupted exception. One second. Had to use the interrupted exception. In the interrupted exception, uh, I'll just some message, that's all. So if whenever the thread gets accepted, that message will be printed, println. So in thread got interrupted, like that we can write thread got interrupted, thread got interrupted. So like this I can just give a message. So this is the logic inside, um, inside this class. Run function. Okay, try is written, catch is also written. So okay, so I think this function is complete. So this function is complete. Mm, okay, okay, okay. So after this, now I will create my threads in demo class. In I will create a class called demo. So inside this class called demo, I'll write a main function. I'll write a main function, public static void main, string args, string arguments. After this, here I'll create the thread. So here I will create the threads. So um, one thread. So I'll just call constructor. I'll just call the constructor. So for one thread, I'll give the name of the thread as this is my thread. So this is my thread. I'll just give it as my thread. So this is my first name. This is my first name. So first thread I've created. First thread. This the line 33 is creating the thread by the name my thread. I want to create one more thread by the name by the name. I'll give it as second thread. I'll give it as second thread. So this is my second thread. After that, I'll create one more thread by the name. mm, One more thread by the name, the last thread, the last thread. So see, these are the names. That's all. These are the names which I'm giving it to the thread. So now in this line, these three lines are creating three threads. These lines are creating three threads. Um, what this lines are doing means, it is creating three threads, one by the name my thread, the second by the name second thread, and the another one by the name last thread. So what this thread will do, what this thread will do means, it will uh, it will um, access. So this threads, they will call the run method. So whenever I'm starting this thread, they will start running, and they'll start printing the values from 1 to 5. So again, again, um, so the threads have been started. So after this, I'll just um, I'll just wait for other threads to end. So for that, I'll just use the try block, and I'll just call this sleep method. So here also I'll make it to sleep for 1000 milliseconds. 1000 milliseconds. Um, let's wait for a few more. I'll make it as 10,000 milliseconds, and again I'll just copy this. So this is for main thread. So the main thread has to wait for other threads to end. No, so that's why I'm writing this. So try block is done. Catch block is done. Main thread, main thread got interrupted. Okay, main thread got interrupted. So this is the program. So this is the program. So um, and also you want to know which thread is completing, which thread is exiting. So for that also you can write one statement. You can write one statement whenever the thread has completed its execution. It can just leave a message. It can just leave a message. So here what I will do means, first if I want to get the first thread to be completed its execution, I'll write it as name followed by exited after completion. Okay, like this I'll write. So this is for the threads. Okay, in this pro here um, after catch also mm, the catch statement here, it will be for the main thread. Here it will be for the main thread. So here I'll just write main thread got exited. Main thread got exited. Exited after completion. So this is the program. So here I'm just creating um, three threads. One is by the my thread, second one by the name second thread, and the another one by the name last thread. So I'll save this and I'll run this. You can see the output. Okay, I'll just wait. It is taking some time for compilation. Okay, so main thread. So you okay? One second. It is taking some time. Okay. Okay. The thread is not. I'll just check this. The thread has to actually the output, like the thread should start printing. The thread should start printing, but here the thread is not printing. Actually, you have to get the outputs like uh, my thread one, my thread two, like that. But it is not printing here. I'll just check whether I missed any statement or not. I've started. The thread also has been started. The function is also being written. The class I've created the okay. Okay. So why um, why the thread was not getting printed means because see the name here I've given as multi-thread. The name of the class I've given as multi-thread, but here whenever I'm calling the constructor, I was calling it by the thread function. So now it will print. When I'm creating the object, no, I have to create the object of the class name. So that's why but I was trying to create the object of a thread class. I have to create the object of this multi-thread, because of that I could not get the proper output. So now that has been rectified. Now you can verify that. So I'll save this and I'll run this. So now you can see. Now you can see. See, you can see each time when I give this, the output will be different. So the output will be different each time whenever I create this, the output will not be same. So that point you should keep in mind, because it will be executing so fast. Now the thread can execute in any order. The threads can get executed in any order. um, the outputs will never be same. So I'll just run the program again. You just check that. See, now the output is different. You observe the output. You observe the output once. See now, see what happened in this scenario was the three threads got created. The first thread to get created was my thread, second thread, and last thread. Then second thread is executing. First time, the second thread is printing one, then my thread is printing one, and last thread is printing one. After that, see, last thread is printing two first, then second thread is printing two, and my thread is printing two. What I want to tell is the order of execution is different. The order of execution is different. So, in order to simplify this, I'll just give it as the name as one, two, one, 2, and also I'll give some space 1, 2, and this I will call it as 3. So in multi-threaded application, the output will always be different. The output will always be different. It will not be in order. It will not be in order. Also, the execution of threads will not be in order. So you can see, you observe the output. You observe the output. Then I will explain this. You observe the output. So three. I've created three threads. So I've created three threads. See here. Here, first the thread one. So this is for creating. Thread one got created, thread two got created, thread three got created. After that, first time one thread is executing. Thread number one printing one, thread number two printing two, thread number three printing one. After that, see here, here it is 1 2 3. Here order is 1 2 3, but here 1 3 2. Again here 1 2 3. Again here 1 2 3. And in the last phase, it is 3 2 1. See, this order of execution is different. The order of execution will always be different. So it will not remain constant. So you cannot expect thread 1 to complete, followed by thread 2 to complete, and thread 3 to complete. It can be any order. Thread 3 might complete first, thread 2 might complete first, thread 1 might complete first. So so you will not get the proper, you will not get the output for the threads in proper order. So it can be random. See, thread got exited. After that, the third thread got exited. After that, the second thread got executed. So the thread number one completed first, thread number three completed second, and thread number two completed last. So I will run the same program. I'll run the same program again. See the output. It is 1 2 3, 2 3 1. Here thread 1 got completed, thread 3 got completed, and thread 2 got completed last. So the output can be in any order. The output can be in any order. So this is regarding the thread. So what this program is doing means, this in this program, I'm creating three threads. I'm creating three threads by using this statements. I'm creating three threads. For each of the threads, I've given the name as 1 2 3. And after that after that, I'll start the thread. So once I start the thread, it will start. This will be the run function, will be the entry point for the thread. It is printing the numbers from 1 to 5. It is printing the numbers from 1 to 5. So to know which thread is printing the numbers, I'm passing the name. Here the name can be 1 2 3. After printing one number, it will wait for 1000 milliseconds. It will wait for 1000 milliseconds. I will also extend this, and you can see the output now. You can see the output now. Save, build. See, 1 2 3 printed, waiting for 10,000 milliseconds. So after that, the next statements will, the next, say after waiting for 1000 milliseconds, the thread 2 is printing. So now 2 2 2. After some minutes, it will wait for 3 3 3. And after that, it will print for 4 4 4 5 5 5. And also, so this is regarding the delay thing. This is regarding the delay thing. So what this program did means, it created three threads. It created three threads, and uh, it got it was printing the numbers from 1 to 5. Each threads were printing the numbers from 1 to 5. So in the earlier program, the main function, the main thread got uh, exited at the last, but here the main thread got exited in between itself. Why? Because of this delay. See, I told the main thread to wait for 1000 10,000 milliseconds. No, here each of the threads were also waiting for 10,000 milliseconds. So that's why. So if you want the main thread to exit after all the threads has completed execution, means you should increase this value. If you increase this value, it will be the thread which will be executed after all the child thread has completed its execution, like this. So this output will take some time. um, okay, so here also the main thread will complete at the last. So this is regarding the multi-threaded example, so where you are creating more than one thread. So now we will talk about isAlive method and join method. So what is this isAlive method, what is this join method? So um, isAlive method means it will check whether the thread is alive or not. So we have so this is like this, so you just neglect this. So what is isAlive method? So isAlive method means it will test whether it is alive or not. So when you will consider the thread as alive means when you are calling the start method. So whenever you call the start method for a thread, then you can know that the thread is alive and the thread is not dead. So once the thread is alive, if the thread is running and it has not completed its task, then this function will return true. Then this function will return true. If the thread has completed its task, if the thread has completed its task and it is not running means it will return false. So what is this isAlive method means? This isAlive method belongs to a thread class. It will check whether the thread is alive or not. When you will consider thread as alive means whenever the start method of the thread class has been called, whenever the start method for a thread class has been called and the thread uh, um, is running and the thread is running and it has not completed its task, then this method will return true. If the thread has completed its task and it is not running, it will return false. So this is the syntax. So syntax you can see, final boolean is alive. So this method will return either true or false. So this is the first one. So if the thread is running, true. If the thread is not running, false. So this is the working of isAlive method. So if I'm running a thread, the output as true, and if the thread is not running, I'll get the output as false. So this is the working of isAlive method. So um, we'll check this with the programming uh, example. So what I will do means I'll write a program for this. I'll write a program for this. So class demo, no, whatever example is there, I'll write it here itself. Class, um, so class demo, how to, which method to follow? We'll follow that implements runnable interface itself. Uh, implements runnable interface. Implements. Okay. Implements runnable interface. So once it is implementing the runnable interface, I should write public void run method, public void run method. So inside the run method, I'll just write one statement. Inside here, I'll just write one statement, thread dot sleep for 1000 milliseconds, 1000 milliseconds. After that, I will write system dot out dot println. So we are checking isAlive method. No, we are checking isAlive method. Is thread alive? So is thread. I'll just is thread alive. I'll just write it as is thread alive so that it will print whether it is true or false. We'll get it as true. If it is returning true means the thread is alive. So we are just asking the question. So this will be just printed on the screen. This will be printed on the screen. So we want to check it for the current thread. So current thread can be obtained by using the current thread function. Current thread function on that we are calling the isAlive method. IsAlive method. Try is done. Immediately try. After try, I have to call catch block, catch interrupted exception. Thread interrupted. I'll just write it as thread interrupted. I'll not expand this further. So thread got interrupted. So after this, I'll write the main function. Run function got completed here. So public static void main. So I'll create a thread class. Demo d is equal to new demo. So before calling the start method, see before calling the, we have to consider two cases. So before calling the start method and after calling the start method. So before calling the start method means the thread will not be alive. So before calling start method, before calling start, before calling start method, we'll check whether the thread is alive or not. After calling start method, we'll check whether the thread is alive or not. So I'll just write that. I'll just write that. So one will be for before calling the start method, and the second one will be after calling the start method. So I've written a thread class demo D. So since we are implementing it using the runnable interface, I'll call it as thread T1 is equal to new thread. For this, the parameter will be demo uh, D. So thread T1 will be so before calling the T1 dot is alive. T1 dot is alive function. I'll call the T1 dot is alive function. So this is before calling the start function. Before calling the start function. So again the same thing. Again the same thing after calling start function. After calling start function. Calling start function. Okay. So now I'll call the start function in between. So I'll call the start function. So what this program is doing now, what this program is doing means we are checking for the isAlive function. So we are checking the working of isAlive function. So what this isAlive function will do means it will return true if the thread is running, and it will return false if the thread is not running. And it will determine whether the thread is alive or not. So for that I created a thread by implementing the runnable interface. So inside the run function, I'm just printing some line whether the thread is alive or not. So after that here I've created a thread called T1, and I'm checking whether the thread is alive or not. So you know that even though if the thread is created, it will start running once you call this start method. So the thread will be in a ready to run state. The thread would have not started its execution. The thread will start its execution only when you call the start method. Even though you have written all the logic inside the run function, you have to start the thread explicitly. Otherwise, the program doesn't um, the program doesn't I mean the thread doesn't start execution. So this is what I've done. So obviously before calling this start method, the thread will not be in running state. So that's why for this line you'll get the output as false. Why? Because I have not started the thread. If since I have not started the thread, how will the thread start running? So in that situation, obviously the output will be false. The second situation, I've called the start method. Once I've called the start method, the thread will start running. When the thread is running, I'll get the output as true. So this is how this program is being written. First situation, I have not started the thread, so I'm checking the align method. So this isAlive method will give our false as the output since the thread is not running. So let me compile this and we'll run this program. Save, run. So you can see. So before calling the start, so I mean this line, I'll go to that line. See, before calling the start function. So before calling the start function, the thread will not be in the running state. So that's why for this, when I'm calling this isAlive function, I'm getting the output as false. Then I will call the start method. Then I will call the start method. After calling the start method, I will call isAlive function. After calling start method, the thread would be in running state. So that's why since the thread is in the running state, I will get the output. I will get the output as true. So this is regarding the isAlive function. So um, one thing is it will return only two values, either true or false. Thread is running, true. Thread is not running, false. So I mean the thread is in execution. Thread is in execution, true. Thread is not in execution, false. So how do you decide whether the thread will start execution means you have to call start method. So the start method is responsible. See, the start method will cause the thread to begin execution. So if you're not using the start method, the thread doesn't start executing. So once the logic for the thread has been defined inside the run method, you should start the thread by using this start method. So this point you should remember. You should remember. So uh, so this is regarding um, the is alive uh, function in Java. So this is the output for that is alive function. So next we have one more function called um, join function is there. We have one more function called uh, join function. So what this join function will do means it this join function um, this join function it will wait for the thread to die means for the thread to complete its execution. So um, what this join function will do means this join function will wait for a thread to die or it will cause the currently running thread to stop the execution until the thread it joins with completes its task. So this is the functionality of uh, join function. So what this join function will do means it will wait. The join function will wait for a thread to die, or it will cause the currently running threads to stop the execution until the thread it joins with will complete its task. So we have the general syntax. The general syntax for this join function is public void join. Public void join. So this is the syntax. So this is the syntax of join function. So it will throw the interrupted exception, and also for this join function you can call the join function without parameter, or if you're passing the parameter it will take milliseconds. It will take milliseconds as the parameter. So like that. So a function, a program related to this join function, we will see how it can be implemented. So once we are implementing the join function by using the program, it will be easy to understand. So we'll see that. Um, we'll say that.